This is lesson 4.3 on writing equations of parallel and perpendicular lines. Remember, parallel lines are always the same distance apart, they never meet, and perpendicular lines always cross at a right angle. So the essential question here is, how can you recognize lines that are parallel or perpendicular? So remember, two lines in the same plane that never intersect are parallel lines. Two distinct non-vertical lines are parallel if and only if they have the same slope. See, there's that key there. They have the same slope. And not to mention, all vertical, remember up and down lines, are parallel. So in our first example here is identifying parallel lines. Determine which of these lines are parallel. If you look at line A here, we have a rise of -1, so -1 over, and a run of 1, 2, 3, 4, 5. So -1 over 5. For B, again, we have a rise of -1 with a run of 4. So -1 over 4. And for C here, again, we have a rise of -1 and a run of 5. So remember, for our lines to be parallel, that means they have to have the exact same slope. So line A and line C are going to be the parallel lines. Even though B looks like it's parallel, the slope is slightly off, so eventually they will cross. So just A and C are parallel. So in example 2 here, writing an equation of a parallel line, we're just going to write an equation of a line that passes through the point 5, -4, and is parallel to the line y equals 2x plus 3. Remember, when we said they're parallel, that means they have the same slope. So we know the slope of the line we're getting ready to write is going to be 2. So here is the part that's a little bit different and new for you, is we don't know what the y-intercept is, but we have a point here. So one of the ways that we could do this is we could plug in the numbers into the y equals mx plus b and solve for what my y-intercept would be. So if I used -4 for y, my slope is 2, and use 5 for my x, I can find out what my b is going to be. So I've got -4 equals 10 plus b, subtract 10 from both sides, and I get my b is going to be -14. So in other words, to write this equation, we are going to have y equals, my m is 2, so it's going to be 2x, and then my y-intercept is -14, so -14. So the equation of the line that is parallel to y equals 2x plus 3, but runs through the point 5, -4, would be y equals 2x minus 14. Now, what about perpendicular lines and slopes? Two lines in the same plane that intersect and form a right angle are perpendicular lines. Now, non-vertical lines are perpendicular if and only if their slopes are negative reciprocals. Remember, reciprocals means flipped upside down. Negative obviously doesn't necessarily mean that it's negative. It just means that the sign is opposite. Because you could have a negative slope to start with, and then the negative reciprocal would be a positive slope flipped upside down. So let's look at a couple examples here. For example 3, we're identifying parallel and perpendicular lines. We're to determine which of these lines, if any, are parallel or perpendicular. So the first thing I want to do is I want to get all of these in y equals mx plus b. That way I can quickly identify what the slope is. For line A, it's already in that form. So I can tell you for line A, my slope is 4. Because remember, the slope is the coefficient of the variable x. Here I'm going to have to solve for y. So I'm going to subtract x from both sides. So I'm going to have 4y equals negative x plus 3. Now I need to divide by 4 to get y by itself. And remember, I must divide everything by 4. So those cancel out, and I'm going to have y equals negative 1/4 x plus 3/4. So what this is meaning is that my slope is negative 1/4. So let's look at C now to determine what slope that has. Again, it's not in my slope-intercept form, so I need to solve for y. Add 2x to both sides. I get negative 8y equals 2x plus 16. I am going to divide by my negative 8. Remember to divide everything by negative 8. So those cancel out, and I get y equal to negative 1/4 x minus 2. So here, my slope is going to be negative 1/4. So now it is asking me to identify parallel and perpendicular lines. Remember, parallel lines have the same slope. Well, I have two that have the same slope. So line B is going to be parallel to line C. That's line B is parallel to line C because they have the same slope. How about, remember, perpendicular have the negative reciprocal. So 4 and negative 1/4. So A is perpendicular to B. Not only is A perpendicular to B, M is also negative 1/4 for line C. So is also perpendicular to C. So we've got B's parallel to C, A's perpendicular to B, and A is also perpendicular to C because we're looking at those slopes. So now how about writing an equation of a perpendicular line? It's asking us to write an equation of a line that passes through the point negative 3, 1, and is perpendicular to the line y equals 1/2 x plus 3. Remember, for this to have perpendicular, the slope needs to be the negative reciprocal. So right now, the slope is 1/2. To be the negative reciprocal, we would want a slope of negative 2. So I'm going to plug in this for my x, this for my y, and solve for my b so that I can find out where my y-intercept is going to be. So y, so 1, equals m, which is negative 2, x, which is negative 3, plus b. And now I can solve and find out where my y-intercept is going to be. So 1 equals negative 2 times negative 3 is going to give me a positive 6 plus b. Subtract 6 from both sides, and I get b is negative 5. So now I have my m, and I have my b. So to write my equation, I'm going to have y equals m, negative 2, x, plus b. My b is a negative 5, so I'm just going to put minus 5. So the equation of the line that is perpendicular to y equals 1/2 x plus 3 that runs through the point negative 3, 1 is y equals negative 2x minus 5. Let's look here at some graphs here. The position of a helicopter search and rescue crew is shown in the graph. The shortest flight to the shoreline is one that is perpendicular to the shoreline. Write an equation that represents this path. First, you need to understand the problem. You can see the line that represents the shoreline. You know the coordinates of the helicopter. You are asked to write an equation that represents the shortest flight path to the shoreline. So we're going to make a plan. You're going to find the slope of the line that represents the shoreline. Use the negative reciprocal of this slope and the coordinate of the helicopter and the point slope form to write an equation. So first we're going to solve it. To find the slope of the line that represents the shoreline, the line passes through the point 1, 3, and 4, 1. So the slope is just going to be m equals 1 minus 3, change in y, over my change in x, 4 minus 1, or negative 2/3. Because the shoreline and the shortest flight path are perpendicular, the slopes of their respective graphs are negative reciprocals. So instead of me needing the negative 2/3 slope, the slope that I'm going to need for my equation is going to be a positive 3/2. Now we're going to use the slope and the point slope form to write an equation. Remember the point slope form we used a little while ago? That's that y minus y1 equals m times the quantity x minus x1. We can use this in this instance because we're given the coordinates of the helicopter, which is 14, 4. So to write that equation, I'm going to have y minus my y1, which is 4, equal to my slope, which is now 3/2 because we were doing the negative reciprocal because we're looking at a perpendicular line, x minus 14. If we go ahead and simplify this, we're going to have y minus 4 is equal to 3/2 x minus 21. Add that 4 to both sides to get y by itself, and I will end up with a y equals 3/2 x minus 17. So that's going to be the equation that represents the shortest flight path for the helicopter to reach the shoreline. Go ahead and finish up your notes, make sure you show them to me, and get started on Clever.